All right, welcome back. So let's begin by talking about objects, talking about them through the lens of Big O and performance. Hopefully you're familiar with them. If not, I don't have time right now to teach them, but I may or may not have some courses on them. So they are unordered data structures, and everything is stored in key value pairs. For example, like this object literal, I'm storing in a variable called instructor. We've got 3 key value pairs. All right, so objects work well when you don't need order, of course, and also when you want fast access and insertion and removal. So no order, but everything else, almost everything else, is very quick. And when we say quick, I'm talking about constant time for insertion, removal, and accessing data. So objects are very fast. I mean, that's the fastest we can go, constant time. We'll come back to searching in a moment. If we hop over here, here's the same exact object. We later in the course have a section called hash maps where we actually learn a data structure that explains how objects work behind the scenes, how things are actually stored. So what happens when we say instructor should have first name set to Kelly, what does JavaScript actually do? A computer can't necessarily just access a place in memory called first name. So there's some additional steps involved along the way. There's something called hashing. We talk about it later in the course. But all that you need to know is that JavaScript is able to add something into an object, store a new piece of information in constant time. It's also able to retrieve something in constant time, and you could also update something in constant time, which is really the same as retrieving it. You're just changing it. Same with removal. So it's quick, it's fast for all the basic operations. There is no order, so there's no beginning of the object, there's no end. So it doesn't matter where you insert because there is no where. That's a bad way of putting it, but you can't insert at the beginning or in the middle or the end of the object. There's no repercussions. You just add in using a key. All right, so insertion, removal, and access are all constant time, very quick. If you want to learn more, remember there's a section on hash tables and hash maps where we go into that, and you'll hopefully understand how it is constant time. Searching, however, is O of n. It's linear time. And when we say searching, it doesn't mean looking for a key, for example, first name, because as we've already seen, accessing information with a key is constant time. What I'm talking about is checking to see if a given piece of information is in a value somewhere. If it's on this side of the colon, we have no easy way of doing that. We would potentially have to check every single item, every property. So that's what this little black box is signifying, or green box, I guess. If we wanted to know, is true stored in our object somewhere, we'd have to check. First name, what's your value? And then we look at it, it's Kelly. All right, that's not it. Is instructor, what's your value? True. All right, so there is true in here. But potentially, as the number of properties in there grows, as n grows, so does the amount of time it takes to do that. So now let's go on to some of the methods that objects come with. Things like keys, values, and entries. Those 3 are all O of n. So if we hop over back to Chrome and we take a look at keys, so it's object.keys, and then we pass in the object. So if we do it for instructor, we get this array with the keys. This is O of n time, because as the number of items in there grows, we're going to have to visit every single thing once and add it to this array. We're not going to, but the source is going to do that, the code. Same thing with values. Hopefully that makes sense. If we have 100 elements or 100 properties in our object, there's 100 things, 100 operations we need to do. There's usually more, but it runs roughly in line with n. It might be 2n, it might be 50n, but that still simplifies to O of n. And then that also is the same for entries, right? And technically entries is a little more work, potentially having to compile the key and the value, but it all just simplifies to O of n at the end of the day. Remember. Okay, so lastly, we've got has own property. And has own property is a little different. We pass in a property like first name, and it just tells us it has first name, or it doesn't have first name. And this is constant time. And hopefully that makes sense why it's constant time. If we're able to access information in constant time, if we have the key first name, we want the value. We should also be able to check if a key exists in pretty much the exact same time. So in summation, objects are really quick for pretty much everything. However, there's no order. And as we'll see coming up with arrays can be pretty fast for a lot of things, but the order also can slow them down depending on what we're doing. So objects are basic. They work very well in a lot of situations. Key value pairs, all the main operations, inserting, accessing, updating, removing, all constant time. Searching is pretty rare, but it is O of n. It grows as n grows. It's linear. And then the methods like keys and values and entries, where we're creating an array based off of the data inside the object. Well, as the object grows, so does the number of operations, the amount of time it takes to compile those. So those are O of n. Okay, so next, arrays. A little more interesting because there's some variation. There's some nuance to it. That's coming up.